Hello Year 7, this is Miss Nurhan. Today we're going to talk about the second topic in Term 3. According to the syllabus plan, Unit number 4, Variation and Classification, our second topic, Variation in a Species. So our lesson objectives today are: number 1, to compare the variation in the same species; number 2, to represent the results with frequency diagram, and the keywords are variation and frequency diagram. Let's begin our lesson today by revising some information from the previous topic. In the previous topic, we talked about species, which is a group of organisms that all share the same characteristics or features. Characteristics means features of an organism. These features, sometimes you can see it like face shape, hair color, skin color, and sometimes you cannot see it like blood group. And also he said that the species has another definition, is a group of similar organisms that can breed with one another to produce fertile offspring. And we talked about a hybrid animal, which is an organism that produced when two organisms belonging to different species breed together. Also, we talked about a scientist called Carl Linnaeus. In 1735, he decided to give every species a two-word Latin name. His system meant that every scientist could use the same name for the same species. For example, our species is called Homo sapiens. Today's lesson is talking about the variation in the same species. And as you know, all humans have different combinations of characteristics, which means we all look different. For example, these people all are from the same species, Homo sapiens. But how many differences between them can you spot? Yes, a lot. Some of them are males, some of them are females. They have different hair color, they have different skin color, and also their face shape is different. So this means there are some differences between the individuals of the same species, which means variation. So variation here, it is the differences between the individuals of the same species. For example, these two sharks are from the same species, Carcharenius melanipetris. They have different tips. One of them is called the white tip reef shark, and the other one is called black tip reef shark. Also here we have another example for plants. These two trees are from the same species, Cornus florida. One of them produces pink flower color and the other one produces white flower color. These dogs also are domestic dogs. All belong to the same species, but the members of the species are not exactly the same. Now let's have a look on questions, page 56 in the course book. Question number 1a. Make a list of 5 kinds of variation that you can see between dogs in the photograph above. If we look carefully at this picture, we will find some of them are vary in their size, shape, ear length, color, hair length, and so on. Question 1b. Suggest why scientists classify all domestic dogs in the same species even though the different breeds of dogs show so much variation. Actually, this question, its answer we can find it in the previous lesson. In the previous lesson, we talked about the species and we said in the organisms of the same species, they can breed together to produce fertile offspring, right? So our answer here, because all the different breeds of domestic dogs are able to breed with one another. Question number 2. The flowers in the picture above all come from the same species of daisy plant. Question A. What characteristics do all of the flowers share? Yes, they have yellow centers, they all have white petals, the shapes of the petals are similar. Okay, question B. Make a list of ways in which these flowers show variation. We need to look at their differences. If we look carefully here, we will find they have different number of petals, their diameters are different, their sizes of petals are different. Now it's time for activity. All humans belong to the same species, but none of us is identical with any other human. Even identical twins have some small differences. In this activity, you have to choose 4 or 5 features that vary among the members of your family. Then you are going to construct a results table like this one. After you finish your results, collect your results and put it in this table. I will give you an example. For me here, I have chosen this family which has 3 members, father, mother and a child. This family shows variation in their hair color, eye color, show size and their heights. As you can see here, for the father has orange hair, the mother has brown hair and the child has orange hair. Also they are varying their eye color. For example, the father here has blue color and for the mother has brown color, the child has brown color. Also they are varying in their show sizes and their heights. Now you know how to do the activity, so I will give you 1 minute to discover the variation in your family. Don't forget to put your results in a table. Now we are going to talk about the frequency diagram. Frequency diagram is a diagram shows the number of individuals with each variation of a variable feature. For example, a species of a plant called the kidney beech has flowers that show variation in color. A student count the numbers of plants with each color of flower growing in a small area of a field. She recorded her results in a table like this one. And as you can see here, she made 3 rows. 1 row for the flower color, 1 row for the tally, and 1 row for the number. In the color row, she put the colors of the flowers: red, pink, orange, yellow, and green. And for the tally row, she put stalks. Each stalk represents 1 flower color. For example, if she found 1 red color flower, she will put 1 stalk, and so on. After she finished the tally row, she put the numbers of stalks in the number row. For example, for the red flower color, we have 5 stalks. So in the row of the number, she put 5. And she put 2 for the pink, 3 for orange, 9 for yellow, and 3 for green. After she finished her results table, she drew a diagram like this one. In this diagram, we have 2 axes. One axis represented the number of plants and the other axis, which is x-axis, represented the flower color. Here, we can show the pattern of variation in a group of organisms using frequency diagram or as bar charts. Let's have a look on questions, page 57 in the course book. Question number 3, how many plants did the students find? To find the number of plants, we need to add all the numbers that we have here. 5 plus 2 plus 3 plus 9 plus 3 equal 22 plants. Question number 4, which was the most common flower color? So here we need to look at the highest number, which is 9. 9 represents the yellow color, so our answer will be yellow. Question 5. The student recorded her results in a results table and then in a frequency diagram. Which of these do you think shows the results more clearly? Explain your answer. See, in this question you can write your own answer. But for me here, I have chosen the frequency diagram, which shows the results more clearly, as it is easy to see the relative heights of the parts. For you, you can write the results table, so it's up to you. Now let's have a look on questions page 36 and 37 in the workbook. This exercise, it has a paragraph. The students in Nisha's class come from many different countries. Nisha recorded the hair color of 10 of her friends. These are the results she wrote down. Question number 1. Complete Nisha's results table. As you can see, this table has 3 rows, one hair color, the other one tally, and the last one number of people. To fill the first row, we need to look for the hair colors here, which are black, blonde, brown, and red. And for the tally row, we are going to put strokes which refer to the hair color. For example, for the black color, we have Ahmed, so we will put 1 stroke, Jenya, Jinjing, Lakshan, and Raphael. So we have 5 strokes. For the blonde color, we have Raquel and Kay, so 2 strokes. For the brown color, we have Shane and Dane, so also 2 strokes. For the red color, we have only Dervia, so 1 stroke. For the last row, we are going to put the number of strokes. So we'll find the number of people. For the black color, we have 5, blonde 2, brown 2, and red 1. Question number 2. Complete the frequency diagram to show Nisha's results. Here they put the axis for you. On the y-axis, they put the number of people. On the x-axis, they put the hair color. So we'll start to put the origin point 0. And then we need to look at the highest and the lowest number in the table. So the highest number is 5 and the lowest number is 1. So our scale here is easy. We'll start from 0, 1, 2, 3, 4, 5. And on the x-axis, we'll put the hair colors: black, blonde, brown, and red. Then we will draw the 4 shorts. For the black color, we have 5, blonde 2, brown 2, and red 1. Okay, now we will go to the Skills Builder page 24 and 25. But this time I'm not going to answer with you, you are going to answer alone. And then you will pause the video. After you finish your answers, open the video again to check your answers with me. Okay, for question number 1, complete the last row of Amal's and Sam's results table. As you can see here, he wants us to fill the number of plants, which is easy. We just need to count the number of strokes in the tally row. For the yellow color, if we count the numbers, we will find them 6. And for the white, 3, red 4, and the orange 7. Question number 2, calculate the total number of canna plants. We are going to add all the numbers together, so 6 plus 3 plus 4 plus 7 equal 20 plants. Question number 3, use Amal's and Sam's results table to draw a bar chart. Put flower color on x-axis and the number of plants on the y-axis. So first we are going to draw the 2 axes. Second, we are going to put the origin point. Then we will look at the highest and the lowest number in the results table. The highest number is 7 and the lowest number is 3. So our scale also here is easy. starting from 0, 1, 2, 3, 4, 5, 6, and 7. And for the plant color, we'll put yellow, white, red, and orange. Then we are going to draw the bar charts like this one. For the yellow 6, for the white 3, and red 4, last one orange 7. Question number 4. All canal lily belong to the same species. What word do we use to describe differences between individuals that belong to the same species? Adaptations, features, frequency, or variation? Yes, exactly, variation. Before ending our lesson today, let's summarize what we have taken in today's lesson. In today's lesson, we talked about variation and said variation means the differences between the individuals of the same species. And we talked about the variation in sharks, the variation in flowers, and the variation between humans. And also we talked about the frequency diagram, which is the diagram shows the number of individuals with each variation of a variable feature. Now we reached to the end of our lesson. I hope you have enjoyed today's lesson. Stay safe. See you next time.